Alright, um, got a little differential amplifier I built. Now this textbook that I'm testing with analog discovery, and here, right over here, is the circuit for it. Here's a circuit board for it, but this is the basic circuit, and you know, like I said, differential amplifiers. Um, this is an example of one in the book, and it's one I'm simulating here on Falstaff, but it's not the one I built. I've used slightly different resistors, but the principles are still the same. The currents will be double because I used half the resistance you see over here. But generally speaking, it's still basically this one in the book, and you can see, the nominal currents are supposed to be about half a milliamp or so, and on mine they'll be about 1 milliamp and 2 milliamps going through the tail here. Um, so, but basically, yeah, you get pretty high gain out of this thing. Let's see. Kind of show you the results, of analog discovery. I ran a, bandwidth test, and we're getting a gain of about, let's see if I can get this focused in right. Yeah, a gain of about, geez, I still don't know if you can see that. Anyway, a gain of about 150, so I don't know if I'm going to be able to get it focused in enough on this. But the gain is about 150, and it craps out at starts to lose gain at about 30 kilohertz or so. And geez, it's hard for you to see it. But yeah, I guess that's about as good as it's going to get. But yeah, the gain starts to crap out at about 150 kilohertz or so, and this is pretty much the output. And like I said, I'm having to put God, this sucks. I have to keep adjusting this fucking focus. But yeah, you can see the the input I'm putting in is like about 25 millivolt signal right now if I run it, and then you'll see that. So my little gain formula up here is agreeing with the other thing about 150 or so. So of course you can't see that either. Well, there you go, you kind of can. But yeah, I mean, it's, I got it set down, and of course, this thing's, plus or minus 12 volts being supplied to it. So, the higher the voltage you supply, the gain does kind of sort of increase, I guess. Let's say I can up voltage on there, and you can see it's up to 18 volts peak to peak now. It was 10 before. If I continue to increase it, you can see it's starting to distort, but it'll actually go pretty broad range. Remember, that's the peak to peak voltage there at 21 volts. You can drive it up towards clipping, get a 22 volt output, but it's really just a 11 volt output, but it's AC because I'm actually doing a differential measurement on it, and so we're getting much higher gains because of that differential setup. See, the two blue wires are the outputs, and I got my probe across it. Two white wires, if you can see it, are the inputs. So, and I'm only using one of them, so I got a single-ended input but a differential output. So, but anyway, it's a neat little circuit, to investigate differential amplifiers. So it's, which are used especially by ESP guy, Elliott Sound Products. You'll see it all over his, most of his amplifier designs have a differential amplifier as part of the input stage. Apparently, as long as you keep the signal pretty low, it's linear. But you can't. There's no like feedback mechanism built into this, and usually an op amp is just part. Differential amplifiers. The part of the input stage of the of a greater amplifier like an op amp or something like that. So, but at any rate, thought I'd share that with you. But I did want to add that, like for example, my configuration, I've got the input, signal going to one of the inputs and nothing going to the other, so it's a single-ended input. But this is a differential amplifier too, so I mean I could put two different signals in there and get the difference between the two, or the same signal, and you could look at the common mode rejection, which I guess we could try that. But I wanted to say that right now this amplifier is activating this transistor, and for the differential mode, basically it's acting like a follower, a voltage follower, a common collector amplifier. So this Q1's acting like that and passing that signal along to the Q2, which acts as a basically a common base amplifier. So that's where most of the voltage gain is actually coming from. And then this transistor, I pretty much is acting like a common collector amplifier for its own output. So, and I'm measuring my probes across this, so I'm doubling the output. If an op amp usually only uses one, of the outputs, from a differential input. In fact, most amplifiers tend to, and they just kind of ignore the other. A lot of times you won't even see a, collector resistor on the other one. But it still produces, pretty decent gain, even without a constant current source. But if you replace this resistor, with a constant current source, because the gain of this, amplifier is actually 2 times RE. You can see it right here. It's maybe kind of hard to see this. It's basically the collector resistor divided by 2 times the RE prime. And the RE prime is figured by dividing 25 millivolts by the current, and that's why I'm probably not going to get as high of a gain, because my current's higher than the one in the book, which had half the current. So it'll have lower current going through the emitter, about half the current, but it'll give you double the gain, because that 25 millivolts divided by 0.5 milliamps, would be, honestly, twice as large of a resistance. So RE prime would be double what I have in my circuit. So this one here would have higher gain because it's based on 10K resistors instead of the 4.7s in mine. So yeah, the gain would be through the roof, well over 150 or more, or 250 or more, because that would be divided into 10K, which is also a larger resistor. So you got a smaller resistance, divided into a larger resistor, so you're definitely going to get more gain out of it, than mine. So, but frankly, I'm thankful I didn't get more gain, because, this is kind of, pushing the limits of analog discovery a little bit right now, in terms of how small of a signal that you can practically generate. Because you can't go too low, and I've got it at 20 millivolts right for testing anyway. But if I had more gain than that, I'd probably have more difficulty doing that, perhaps. Maybe not, but I know my signal wouldn't have as much resolution, especially if I wanted to have a distortion-free output, like you see down there. But yeah, I mean, we can test the common mode real quick, because I mean I did actually build up a common base amplifier too, I didn't make a video about it, but yeah, I mean, it had a gain of 100, you know, with the analog discovery going into it, you know, and pretty good bandwidth because the analog discovery's got really low, you know, rather low output impedance for the most part, at least at lower frequencies. So yeah, I mean, it actually had pretty good gain, you know, but oftentimes, you know, common base amplifier usually has such low input impedance because it's based on RE prime. You know, that's pretty much its input impedance. So, you know, if you have too high of an output impedance source you know, hooked to it, you don't get much gain. It really screws your gain up. So a lot of times you'll get, you know, like 5 or 10, you know, as a voltage gain out of a common base amp, and you know, there's no current gain in a common base amp. But anyway, hold on. I'll hook this up in common mode and see what happens. Okay, so basically, you know, it's still operating normally. Now I'm going to short my two input wires together, okay, and that'll effectively, you know, put it in common mode because the signal will go to both inputs. Now, watch what happens when I do that. It's a little squirrely, but to get it, there we go. All right, now our output signal is almost totally vanished. You know, because the blue traces are input, you know, the yellow traces are output. So yeah, it's like totally vanished in common mode. I just released the wires and we're back to single mode again. So anyway, you know, just wanted to demonstrate that little facet too. So that differential amplifiers do have that advantage. You know, that's one of the big reasons that you have common mode rejection in an op amp. So anyway, that should about wrap it up. So cheers.